everyone, and welcome to this video. In this one, we're going to look at the integration of your CMake project with popular editors or IDEs like Visual Studio Code, Microsoft Visual Studio, C and all these cool tools that people use with C++. And CMake provides a system called CMake presets. That's what we're going to look at here. But first, let's look at why we need them. They are a way to configure your project in a declarative way, so you specify the settings that your project is going to use, and these settings are stored in a relatively standard way that everybody is going to see and understand. This is something you can achieve, for example, by writing a Python script, a batch file, a bash script, but these things are not standard. Everyone is going to do these things in a different way. CMake presets are a way to try and standardize the way we store the settings pertaining to the configuration stage of our project, the build stage, or even the generation stage. They are pretty cool and they make your life easier as a CMake C++ user. They make it easy to configure your project for different platforms, so you can specify configurations for the Clang compiler, for example, or even a cross tool chain. If, for example, you are on Windows and you want to compile for a Raspberry Pi, you can put your settings in a CMake preset file, and these settings will be picked up by a system that supports your particular configuration. This is really cool. You can share your configuration easily, so if you take them from your computer on Windows and clone your project on Linux, the settings are going to be picked up by your Linux machine and you will be building instantly. IDEs and editors use them to configure your project. You will see that VCPKG and Conan have good support for CMake presets to make things really easy. But one thing I like about presets is that they make it easy to debug and test your C++ project, something we haven't really talked about. We have talked about testing, but we haven't seen how you can debug your CMake project. We will be able to do that in this video for the first time. This video is going to be pertaining to VCPKG, but in the next video, I will show you how to do it with Conan as well. So you will make your choice as to which package manager you want to use with your project. Either is going to work. So let's see more about these CMake presets. There are two types. And all these files will be living at the root level of your CMake project. The CMake presets is going to be something that you will check in your source control system. So for example, you will add it to Git. You will let something like Git manage it. A CMake user preset is really something that is pertaining to your particular system. If you have a setting that is only applicable to your local system, but you don't want other people to pick that up, you will put that in a CMake user preset JSON. And the preset system is going to take all these files and merge them together to have one set of settings that your project is going to use. I think we can go to the documentation and see this in action. So let's search for CMake presets and read what the official documentation has to say about this, because what I just told you is my understanding of them. They say one problem that CMake users often face is sharing settings with other people for common ways to configure a project. This may be done to support CI builds to integrate with your continuous integration system. For users who frequently use the same build, CMake supports two main files: CMake presets and CMake user presets, and these are all JSON files. They allow users to specify common configure options and share them with others. CMake also supports files included with the include field. What this means is that you can include preset files in other preset files, and I think we will see an example of that with Conan in the next video, so stay tuned for that. They have a syntax they have to follow. Here they give us an example. This is the content of a CMake preset JSON. So you have a version, you have a minimum required version. You can include other preset files, and this is how you do it. You can specify configure presets. These are things that are going to apply to the configuration stage of your project. So this is a configure preset. You can give it a name, a display name, a binary dir, which is the location where your artifacts are going to be built. You can set up cache variables in a preset file like this. You can set up all kinds of crazy things. You see that they are even setting up an environment variable. This is really cool. So you can set up configure presets. That's what I am trying to say here. But you can also set up build presets. And these are configurations that will be used to build your project. So you can set these up. You can also set up set presets. Both build presets and test presets have to link to a configure preset that they link to. So you can see that our build preset here is using our configure preset. If you go up, you will see that our configure preset is named default. Let's go up and show you that. You can see it's named default here. So we have one or more build presets and one or more test presets. You also have package presets, workflow presets, but we're not going to talk about these here. Honestly, I haven't used these myself. What I use basically is configure presets, build presets, and test presets. Let's come back to our project and show you what we will do here. So we will put our CMake preset file in the root project of our folder. And the question that pops up right now is, where do you get your preset file? You can write it yourself. Some people write these things themselves. But personally, I have a weakness for these things. I usually can't get them right. So I let my tools generate them. For example, I can use Conan to generate a preset file. I can use other tools that I will show you later on to generate preset files that then I use as a starting point. But for this project, I wanted to make sure that I give you something that has a chance to run even on a Mac. So I got one from a project that I follow, which is Endless Sky, that uses CMake. So if we go here, we will find the link. And if we go to their GitHub, we will see the source code. And I used the CMake presets JSON file they provide as a starting point. So I took it, I edited it, I basically removed things, and I set it up to use the MSVC compiler on Windows. This is what I used as a starting point, and I got to what I have here. So let's look at this file. We have a version, we have the configure presets. In the configure presets, we have many. So you see that this is a preset, the base one is a preset, and one thing you should notice is that it is a hidden preset. Let's make sure you can see that it is a hidden preset because we set the hidden property to true. It is going to be using the Ninja generator. This is what we are saying here. And our project is going to be built in the build folder and use the preset name. So if we have a preset name, for example, that is named Windows Base, we will be putting our build files into build/Windows Base. This is what we mean here. It is possible to inherit a preset from another preset, and this is exactly what we are doing here. The Windows Base preset is going to be inheriting from the base preset. And if you remember, we made this preset hidden, and what this really means is that we can't use it directly. The base preset can't be used directly. You can think of it as an abstract C++ class that you can't create object out of, but it is meant to be inherited by other classes. It is the same idea here. The base preset is meant to be inherited from, and if you want in your project, you can use the Windows base preset here, but you can't use the base preset. It is meant to store settings that are going to be used by other presets that will be inheriting from this. This is the system we have here. Again, you can read the documentation for all these things that we have in our preset here. I will try to explain things that are not obvious. You can specify the architecture this preset is going to be pertaining to. You can specify cache variables. You can really do all kinds of crazy things. So we have a Windows-based preset. Let's look at it. We have a Mac OS preset, which is supposed to work on Mac using the default Clang compiler. We will be doing debug builds on a Mac, and you see it inherits base, and it is automatically going to pick up these properties here. For example, we will be using the Ninja generator. We will be writing our files in this build directory here. If we go down, we have one that is going to be used on Linux. We will be using G++, so you need G++ installed on Linux. These are things we have here. We also have build presets, and you see we have name, description, configure preset. This is the most important thing. If you ask me, it is going to link to a given configure preset that we have used, and we will be using those configure options or settings, if I may call them like that. We have Windows clean build, which is going to clean before it builds, and that's going to happen because of this setting here. We have Windows verbose build, which is going to pass the V option to Ninja, and this is what we do here. Again, you can read the documentation for this setting here. We have macOS clean build, we have macOS verbose build, we have Linux clean build, and we have Linux verbose build. These are our build presets. If we go down, you also see that we have test presets, and these are going to be used to integrate our tests with whatever editor that we are using here. Again, we will be linking to a configure preset and say other properties that pertain to this test preset here. We have one for macOS, we have one for Windows, and we have one for Linux. These are things that you can use in your project here. I know this may be confusing for some of you. Some of you may be saying, Daniel, why are you showing me another JSON file? I can build my project on the terminal already. Yes, you can do that. This is a project we have done before. And if we come to Reveal File Explorer, go inside Windows Base, I think we can even nuke the entire Windows Base folder. We're going to clean everything. Visual Studio Code is already using this, so it's not going to allow me to delete this. But if I close Visual Studio Code and open it again, the build folder is going to be empty. So let's ignore all these errors here. It is possible to build this project manually. Don't forget that. So we can say terminal here and say CMake. We're going to configure the project. The source folder is going to be this one. The build folder is going to be the build folder, and you can configure, and it is going to do whatever is necessary to build the project here. Okay, so it's going to install things using VCPKG. This is everything we have done, and it is going to work fine. But we need good integration with the IDE here. For example, we may want to have a nice visualization of our tests. We may need to be able to debug our project, which is really the main selling point for me here. So that's what we're going to do. You see that we have configured this project, but this is not the way we're going to go. So I want to go back and delete whatever we have generated as part of our build here. So let's A and delete. And we will be using our presets. The first thing I want you to see is that you can use the presets on the command line. So let's do that. We can say CMake list presets. And this is going to list all the configure presets that you have available. So Windows base, macOS base, Linux base, we are on Windows. So what we can do to use this Windows preset is to do CMake preset and say Windows base. Okay, that's the name we're going to specify here. If we do that, it is going to see that we have chosen those settings, and it is going to configure our project to use those settings pertaining to that preset that we have chosen. You see that it is going to say that it can't recognize the CL compiler. This is because I started Visual Studio Code from a terminal that doesn't have the environment variables for the CL compiler. What we can do is open developer prompt for PowerShell, developer shell for Visual Studio, and we can cd to this project. What can I do to get the location of my project here? Let's do that. We're going to go to episode 30. That's where we want to go. I am going to copy the path here, and I am going to cd to that location from my PowerShell window here. So cd to that location. I am going to go there, and now I can use my preset because this shell knows about the CL compiler. If I call it, you see that I am going to get some output from it. So I can say CMake preset Windows base, and now it is going to configure. It is going to find the CL compiler, and it is going to complain again. What is going to happen? What is happening here? It is saying, okay, let's try again. I think we need to try and clean the build folder. So let's go back and nuke Windows base here because this was generated earlier. Let's try again. So we're going to use this preset and see what happens. And as we wait for this, if you found this video useful, please remember to share your feedback. Please like, share, and subscribe. That's going to help the YouTube algorithm pick up this video and tell other people that it is really good. So make sure you do that. That's going to help me out. It is going to configure the project basically using the settings we have in our Windows base configure preset. That's what we just did here. And once we have our project configured, we can build it and do whatever it is we want to do with it. But again, this is not the power of CMake presets. The power comes from the integration with tools like IDEs and build systems. And this is going to make your life really easy. But if you want, you can use it on the terminal. And I see some people do that. But that's not what I really like. I can already use CMake on the terminal. So why do I need another JSON file for that? But the real value comes when you want to debug your project. But I will let this finish to show you that it can actually work. And we will cd into the Windows base folder, which was generated for us by our build. Again, remember that our build files will be put in the build folder and in a folder that is named after our configure preset, because that's the setting we are using here. If we go to configure presets, we have base. And the binary dir is set up to source dir build preset name. That's why ours is going to be put in a folder named Windows base, because this is the preset we are using here. I hope this makes sense. It is going to say Doxygen found. It is going to write the build files in this folder here. You notice build Windows base. We can cd there. So let's do everything from our terminal here, because that's going to be easier. Cd build Windows base, and we can CMake build and specify the current location. This is going to try and build our project, and we will be able to use it. And you saw that we used our configure preset. So the build is good. We can run. Let's do debug GUI. Let's do ls and see what we have. Our files have been put in this folder, so we can directly run GUI here, and it is going to run. This is going to be using the SFML library that we pulled through VCPKG, if you remember that. But this is working. Let's again take out this build directory. We want to do this from the IDE. So let's go back and delete this Windows base folder again. Now we want to do this from Visual Studio Code, and the power of presets is going to shine through. Let's do that. So you notice that we have a bunch of settings in the status bar here, but if you don't want to use them, you can do View, Command Palette, or hit Ctrl-Shift-P and then choose Select Configure Preset. For this to work, make sure you have a CMake preset in your project, and you can easily get this from the Git repository of this project here. We will select Windows base as a configure preset, and you go again, Command Palette, select Build Preset. So we do that and we choose Windows Verbose Build, for example. If you want, you can choose Windows Clean Build, which is going to clean before it builds. And we should also select a test preset. So select test preset. We choose Windows Core Test. And now our project knows the settings that it is going to use to build the project. If you look in the status bar, you see that we have a configure preset, we have a build pretest, and we have a test preset. And now our project knows the settings to use to build this project here. So if we want to build, we can just hit build on the status bar. If you don't see this status bar, make sure to go in your .vs code folder, open the settings JSON file, and make sure you have the settings that I have here. You have to set the status bar visibility to visible to be able to see this guy. If you want, you can use presets always, but this is up to you. Now, you can see that the build has finished, and this is fully integrated inside Visual Studio Code. Once the build is finished, you can choose what executable you want to run. So for example, you can hit the setting here in the status bar. Let's make sure you can see it. So you can go on your status bar and hit this button here. And if you hit it, you will have a window to let you select what you want to run. Let's say we want to run the rooster binary, and we hit the run button here. You will see that it will run and give me output. I can change this to GUI. So let's change this to GUI. You see it's going to change down here. If I hit run, it is going to run my SFML application. This is really cool. We have another target, which is use FMT. If we hit run, it is going to run that binary and we will see hello world here. But if you want, you can also run your test like this. We have built a bunch of tests. So if you hit run with this selected, this is going to run your tests and give you output here. But you can still run them like we did before by going in the build folder and running ctest. That's going to work just fine. Okay, now we have built our project. This is really nothing new. You have been able to do this all along. The power comes when you want to debug your application. Suppose we want to debug the code in our main function here. So let's go in our run app function. How can we go there? Go to definition. Okay. And we can go down here and put a breakpoint in the run app function here. So we can specify that we want to run the rooster binary because that's what is using our run app function here. Now that we have set up a breakpoint, we can hit this debug button here and notice what happens. Our binary is going to be plugged into the debugger and we will hit our breakpoint. We will have our locals, we will have our registers, we will have everything. And we can step through the project and really do all kinds of crazy things. This is very powerful, and this is going to make your life easier as a C++ developer using any IDE that supports CMake presets. This is the power of this if you ask me. Another thing I want you to see is that you can have a nice visualization of your tests. So if we go in the tab on the left that says testing here, you will see that you have a bunch of tests here. By default, this is going to show these red buttons, which we don't like. In my experience, after I have the project configured and built, I had to close Visual Studio Code and open it again with this project. And then if I go to that tab, I should see my tests. So where is that thing here? Let's build the project just to make sure that everything is in place. Okay, once we build the project, we have that thing here. You see that our tests are visualized. If I want to run the add test, I can click on it and run it. If I want to run the sub test, I can click on it and run it. And you're going to do this if you know that you have changed the code that pertains to this test here. This is very convenient and I like it. I use it all the time in my CMake projects when I happen to be using Visual Studio Code. This is also going to be integrated in other IDEs that support CMake and CMake presets. Maybe I will take a chance to show how this works with Visual Studio or a Qt Creator or a CLion if I happen to be on a computer with that installed. But for this moment, I just have Visual Studio Code here. And it is the editor I use most of the time anyway with C++. Visual Studio Code has become that good. I know a lot of C++ professional developers who are using Visual Studio Code most of the time because it has all the tools, it is lightweight, it stays out of your way. But some people don't like it because it is from big corp, but that's not a big problem. If you wake up in the morning and Visual Studio Code is not there, you can pick up another IDE or editor and you can keep doing whatever it is you want to do. So this is really all I wanted you to see in this lecture, how you can integrate CMake presets in your project. You can read more about CMake presets in the documentation. And the preset file I showed you is not completely mine. I used the one from Endless Sky as a base, and then I modified it to do whatever it is I wanted to do. One benefit I got from that is that I don't have access to a Mac, and this preset seems to have been built with Mac in mind. So it may work if you are on a Mac. If you are on a Mac and you were able to build this project without a problem, please let me know in the comments below. I am going to stop here in this video and I will see you next time.